Hello everyone. Good morning. Myself Shuva, and I'll be presenting the Cooperative Task Coordinator for Network State Changes. How many of you here have worked with multiple applications over a controller so that during reconciliation we see issues if the applications have certain demand for dependencies? Anyone? Yes. So good. So synchronization across control and data planes can be quite tricky the moment we have multiple applications which are coordinating with each other in the wake of a network state change. So those applications have to react to those network state changes and ensure that there is a coordination framework or there is a coordination in place for the data path to be programmed in the wake of a network state change. So the framework that we are proposing here takes care of that and ensures that in the wake of a network state change, the data plane reflects what the controller plane intends to do. So I would be discussing here the overall problem context, the sample problem area. So that would cover what actually is the problem. And then we would actually go into how could we go ahead and solve the problem. So the key objectives to the solution approach, and how the solution approach would be fit in for the design details. I would show you the code reference for the framework that we have checked in and the future work that is planned along for carbon and ahead. So the overall problem context is that in ODL, there are multiple scenarios in which specific network state change has to be reacted by multiple applications. Now, if I take an example, so when a port comes up, we have a logical port, an OF port which is created on top of it. We might have groups that point to those ports and supervisory groups which load balance the traffic flowing through those groups. And we could have a chain of such groups and a flow pointing to the parent group. So ad hoc reactions to such change could actually misconfigure the network state, resulting in ineffective handling of the HA scenarios or even impact on the forwarding plane. So if I take the sample problem area, so that would be the open flow reconciliation. So what is reconciliation in specific? Is basically a provisioning functionality which helps in group meter or flow provisioning such that the switch reflects the intended controller state when there are a node restart, a cluster restart, or a switch restart. Now it is important because it maintains the control and the data plane sync, and in case of applications like the example which I had taken, if there are dependencies between the two, the ordering has to be taken into account. If we miss the ordering, we can have errors during provisioning, and that would result to a traffic drop. And such errors can have cascading effects or a domino effect on the forwarding plane because you have the rules which are wrong. So if you have a group pointing to a port and the port is down, so if your group doesn't get provisioned, your parent group or the flow that is pointing to it eventually fails. So it's a domino effect from there on. So what are the objectives of the solution? The key objectives of the solution is to perform efficient reconciliation in the face of HA and allow multiple applications to participate in reconciliation, minimized amount of design time dependencies and hard code dependencies across applications. So most of the time when we write applications, we think, okay, these are the three applications that's gonna go together. So we can actually hard code the dependencies and we can code it in such a way that it works. But the moment it's shipped to an operator or your customer or a user and some other application tries to access that, we do end up in a lot of errors. So what is the solution approach? The solution approach would be to implement a framework that would solve the generic problem and not a specific instance of the problem. It would react to event-driven tasks and parallels execution of such tasks across event contexts. So an event context here is a switch connection, disconnection, a node going up and down, a port coming up and down, etc. Now we have constructs in computer science which allow us to perform reconciliation effectively. One such that we would be using is divide and conquer. And the most popular Java construct that falls under divide and conquer is the fork join. So what is the solution design for reconciliation? So the priority-based reconciliation coordination framework would offer a state machine approach. What are the advantages? Yeah, you definitely know what state your switch is in. Is your reconciliation starting? Is it in progress? Or is it finished? You can handle various scenarios as to the nodal failures, the switch failures in a much more granular and robust fashion. You can monitor reconciliation. So right now, if I take the OpenFlow plugin, the moment a switch reconnects, it's a cluster DTCL. We react to it, take all the flows from the config DS, and we push it in. But we don't know at what stage the reconciliation is in. If we break down it into granular parts such that each application has a specific set of tasks, we can get to know, yes, this is the place where reconciliation is currently happening. This is a task it has finished. And it is a generic framework for applications to participate in the overall execution. It's not related, it's not just confined to reconciliation, but it can be used for other event-driven tasks as well. So what is the functionality? The reconciliation coordinator is a core piece of the priority-based reconciliation framework, and this is functionally responsible for initiation, state management, and completion of the tasks. So each of the application registers with the reconciliation coordinator multiple tasks that are submitted to it when the applications come up. So it provides a contract which will enable applications to be notified of the turn when the participation comes in. So if I am an application and I have some default flows to be provisioned, some groups to be provisioned, and some flows pointed to the groups, I can basically split it up into multiple different tasks and have a configuration file where I have specified the priority of each task. So when the application comes up, it registers saying, I will require tasks A, B, and C to be executed at priority 1, 2, and 3, depending on the dependencies. Now, when reconciliation starts, it will happen parallelly. So the tasks execute parallelly at each priority and sequentially across priorities. So the moment it kicks in, the applications will be notified, okay, yes, we are going to do priority 1 task. So the reconciliation coordinator will execute all the tasks for all the applications at priority 1, and these happen concurrently. So it coordinates participants and maintains a configurable priority-based task coordination. So that's the configuration file which we are speaking about. So now this is a interesting matrix. So it shows, so on the vertical down is the priority, on the horizontal is the tasks. So this matrix can be sparse, as in all the applications might not have tasks at each and every priority level, but tasks at each priority level for a particular event context. So this is an event context. Tasks at each event context for a given priority can be executed parallelly, and the next priority will execute if and only if all the tasks of the previous priority are completed or aborted. So in case my switch comes up and boom, it disconnects, I can go ahead and cancel all the tasks. So it gives me a flexibility to abort reconciliation also. So yeah, so a priority is a property of the task and not of the application, and reconciliation tasks per priority level can be performed in parallel without conflicts. So on the block diagram level, this is where the reconciliation coordinator sits in. So we have two applications which use the inventory and the config DS for flow, group, parameter provisioning, app1 and app2. And we have two other applications which directly use the RPCs, which are app3 and app4. Now app1 and app2 writes to the inventory config DS, and the DS based reconciliator, which is currently in the FRM, on the event of a node up, will push those flows through the reconciliation manager and the task coordinator framework. And your RPC based applications which provision flows and groups using RPCs can also take part in that. So currently the framework is such that in case you are provisioning using RPCs, you don't even have a handle on when to reconcile. But using this framework, you actually get a handle, because you register with the plugin will invoke the reconciliation manager, which invokes the task coordinator framework, and the framework as shown in the matrix previous, it is a matrix of priority and tasks. So your applications at specific priority levels will be executed. This is a call for a switch connect. So the moment a switch connects to the OpenFlow plugin, we do the handshake. Okay. The plugin registers the RPCs with the OperaDS, and the event context notification that a switch has connected is given to a southbound manager. So what we have done is the reference app for reconciliation is a example application which provisions flows like ACL. So it will match on a particular IP address and a port, and it will say allow or deny. So that is the reference application which we have written to showcase the working of the cooperative task framework. The southbound manager is a wrapper over the RPCs, the add flow, the remove flow, the add groups, the remove groups, with the additional functions that it has the power of doing a rollback in case of an error. So the priority based task coordinator, so the reference app, so any application just as a reference app registers with the priority based task coordinator when it starts up. Now on the event of a switch getting connected, the priority task manager asks the application for all the tasks at a particular priority, and those tasks are executed in a priority order, in an ordered fashion by the priority task coordinator, and that will ensure that the flows in the groups are provisioned on the switch in an ordered fashion. So okay, so the Gerrit is listed here, and the code of the priority task coordinator has been modeled in such a way that each event source is modeled as an entity. So the entities can have two states, either connected or disconnected. And every application registers to a task factory, where the task factory has a name. So it's a string, so it will give you the device context. So the task factory is used to create a list of application specific tasks or recursive actions. Upon the event of a switch connect or a trigger, the task for a specific priority are handled. Tasks for a specific priority are handled in parallel, but the task for the next priority will happen if and only if the previous tasks are all completed or they are aborted. So the moment, in case I have a disconnection in between, so some provisioning was going on and I have a switch disconnect, then all ongoing and future tasks shall be cancelled, ensuring that you get a handle on where reconciliation is and how to control that. Task monitor also will give us the status on where the running priority of the tasks is, the status per priority, and the entity context. So the way it is designed is the task factory creates the parent tasks which fork multiple children tasks which join on completion. So it's a fork join pool, and so the moment I submit a task factory, the task factory takes care of splitting up the task into multiple children tasks, and only when those children tasks complete, your parent task is completed. So in the current model, there are some loopholes, as we do not know when most of the task has got completed. So we cannot control the end of most of the tasks, and error handling is not that robust. So the future work would definitely include making the error handling more robust. And we are planning on implementing the task coordinator framework using Akka, because actor model would be highly relevant in this context, and to enable coordination across clusters, because we have certain requirements of asymmetric deployments in which the same app might not be running at all places. So the actor model for the task coordinator is something which we are working on, and managing the life cycle of the tasks would be much more easier. So this is a work in progress. We are working on it, and currently it's a Gerrit with the OpenFlow plugin. We'll discuss more about it in the DDF as to where it should lie, because it being a very specific piece, let's see where it can find a house. So this is all from me. Any questions? Do let me know. Yes.
So when, for example, an application when you try to produce a list of tasks, so does the application need to specify what kind of event it needs to do this reconciliation?
Yes.
Okay. So it's like to register a data.
So that's why it makes it much more generic. It not only, it can be to any event. So reconciliation is a specific case of a node connect. You can take any creation in the data store, for an example, any DTCL to be one more trigger point.
Okay.
It can be any event.
Okay. And for example, under different kind of event, suppose I have two applications. Both will respond to switch 1 up or switch 2 up. Can the application specify the priority differently under two different events, or it's like uniform priority?
Could you reframe your question once?
Yeah, for example, if I have an application that it says, okay, for switch 1 and switch 2, I both want to do this reconciliation. And so is application 2. So,
Yes.
But are the users allowed to say, okay, under the event of switch 1, application 1 should have a higher priority, but under the event of switch 2, application 2 will have a higher priority. Does your framework allow that, or you don't think that's necessary?
Okay, so that's a good question. Okay, so the point where I mentioned having an entity context in place, so based on the entity context, you can actually have switch specific priorities, but currently the implementation what we have done is a symmetric configuration. So the applications can have different priorities, but for the same event, the same priority will be respected.
Okay.
That ways.
Okay. All right.
But that's an interesting use case. Sure. Yes, sir.
So have you had any design consideration for load balancing on large scale recovery, like major components of the topology that need to be restored? So you're doing this across many ODL servers?
Yeah, so we have tested it. We have tested it across a 3-node cluster with 1 million flows, and the flows pointing to some of the groups. And so we can batch the flows and say, okay, this many, the first 1,000 or 10,000 will be for a priority 1, and these point to these groups. So the groups is at a higher priority because the flows are pointing to those groups. So we have done testing like that. So that's the thing. And even groups pointing to ports. So the way we see it is the interfaces come up first. So that is the first point where the groups pointing to ports would be first provisioned, and the load balancing groups, the select ones, will be provisioned after that. So on a port up, you do the logical OF port handling, and then you have a layer for load balancing, and then you have applications which write flows to take the traffic out on those ports. Sure.
Two questions. First, the question for the event, right? Is it for northbound or southbound or both?
Which one?
I mean, for the event processing or for the task?
Okay, so the event can be any event.
Any event.
The example which I'm taking is southbound, but it can be basically any event.
So my understanding is some event, say for example, from northbound RESTful API.
Yeah.
And some other event might be triggered from southbound packet in.
Okay.
I just wanted to know any difference between the northbound event and the southbound event? Because like a southbound event, they are usually triggered by the management event, but the southbound is triggered from data plane, probably more event from southbound.
Okay, because we haven't taken that into consideration. What we have taken is whenever you provision through the northbound, so it's a data store which it ultimately lands into. So the data change listener is an event for you.
Okay.
So you can have this priority task coordinator sitting or front-ending your applications writing to data store. So you can have actually, that is one consideration. The other consideration is any event from southbound.
Okay. So talking about the data store, usually northbound, related with the configuration tree, and southbound probably for operational tree, right? Data tree.
Yeah.
Okay. Thanks.
Sure. You had one more question, you said. Two questions.
Exactly. The other question is, say, when I start, the second question is talking about the scale up, right? Clustering is talking about the scale up. So for a single node, talking about the scale up. With this proposal or implementation, say, if I can dynamically or at runtime to specify how many cores for this container, this JVM, or the open daylight. So, say for example, if I can specify 2 cores, or at another situation, I wanted to specify, say, 10 cores.
Okay.
Is that possible?
Yeah, we haven't done anything on that. Yeah, that is new. I would like to know more about it. Let's have a chat after this.
We can discuss.
Sure. In case you don't have any questions, thank you all. Have a good day. Thanks. Control on data planes can be quite tricky the moment we have multiple applications which are coordinating with each other in the wake of a network state change. So those applications have to react to those network state changes and ensure that there is a coordination framework or there is a coordination in place for the data path to be programmed in the wake of a network state change. So the framework that we are proposing here takes care of that and ensures. Hello everyone. Good morning. Myself Shuva, and I'll be presenting the Cooperative Task Coordinator for Network State Changes. How many of you here have worked with multiple applications over a controller, so that during reconciliation we see issues if the applications have certain demand for dependencies? Anyone? Yes. So good. So synchronization across a chain of such groups and a flow pointing to the parent group. So ad hoc networks, ad hoc reactions to such change could actually misconfigure the network state, resulting in ineffective handling of the HA scenarios or even impact on the forwarding plane. So if I take the sample problem area, so that would be the open flow reconciliation. So what is reconciliation in specific? It's basically a provisioning functionality which helps in group meter or flow provisioning, such that show you the code reference for the framework that we have checked in and the future work that is planned along for carbon and ahead. So the overall problem context is that in ODL there are multiple scenarios in which specific network state change has to be reacted by multiple applications. Now if I take an example, so when a port comes up, we have a logical port, an OF port which is created on top of it. We might have groups that point to those ports and supervisory groups which load balance the traffic flowing through those groups, and we could have that in the wake of a network state change, the data plane reflects what the controller plane intends to do. So I would be discussing here the overall problem context, the sample problem area. So that would cover what actually is the problem. And then we would actually go into how could we go ahead and solve the problem. So the key objectives to the solution approach, and how the solution approach would be fit in for the design details. I would